This is the second video on inequalities. In this video, we are going to talk about translating inequality statements from word problems and solving those inequalities. So an important aspect of translating is that we have to connect keyword phrases with the operator, the inequality operator. What do I mean by the operator? That's these guys, greater than, less than, greater than or equal to, and less than or equal to. So we want to look for words like more than in the word problem that are going to connect us back to that operator. For less than, we might be looking for a word like below or fewer than that would give us a clue that we are talking about that operator. Common phrases for greater than or equal to, at least, or minimum. And for less than or equal to, at most, and maximum. Now, I'm not going over all of these. If this is new to you and you haven't seen this before, or if it feels like you need a refresher on it, I would encourage you to stop the video or pause the video, take a screenshot of this, take some time to study these phrases so that you're more familiar with which one connects with which operator. So let's just make a simple example here. This statement over here, wash your hands for at least 30 seconds. Which of these operators would we use? Well, we can see that at least is in this group. That means it should be greater than or equal to. And we are greater than or equal to the number 30. Now, often when we build these statements, we will include a variable in it, like x. X is greater than or equal to 30. Now, if you're having some trouble picking from these, try to keep in mind what values would be true for this statement. If you want, which values would be okay? If you washed your hands for 30 seconds, is that okay? Yes, it says at least 30 seconds. 30 seconds is good. 31 is also good, or 32, or 60, or 5 minutes would be good. Any number larger than 30 seconds is good. It makes this statement true. All right, with that, let's move on to a more typical example of a word problem. A kid's party place charges $40 for the room, plus $6 per child who attends a party. Joe wants to spend no more than $110 on a birthday party. What inequality expression could be used to find the number of children, and we're going to let the number of children be the variable C, who could attend with that budget? All right, in a problem like this, we should focus on putting the cost statement on the left-hand side. And what I'm going to do is to say, well, if it's $6 per child, we want to multiply 6 times C. That's going to tell us the cost that's based on the number of children. But then there's an additional cost, right? They're charging $40 just for the room. So we better add that. So the total cost for this party is going to be $6 times the number of children, C, plus $40. Now, Joe wants to spend no more than $110. Notice that no more than is right here. No more than connects with the less than or equal to. So Joe's okay spending $110, but she's also okay spending less than $110. So it makes perfect sense, less than or equal to $110. And that's how we build an inequality statement out of a word problem. All right, let's clear that off. Now, Let's move on to steps to solving inequalities. That's the process of simplifying this to a more simple statement where X is all by itself. We're going to use the same steps as we did with equations, using opposite operations on both sides, with one important change. We are going to flip the direction of the inequality sign if we divide or multiply by a negative number. We're not going to get into why that's true. We just want to accept that we need to do that. And in the example that follows, I will have an example like that. But that is the major takeaway in solving these kind of problems, is that we always want to be aware that if we multiply or divide by a negative number, we are going to flip the direction of the sign. All right, let's take a look at problem 1 here. The last thing that was being done to the variable side was to add 40. So let's subtract 40 from both sides. And that gives us 6c is less than or equal to 70. It doesn't do anything to this inequality sign. It just keeps following us along. The only thing that changes is if we multiply or divide by a negative number, we're going to change the direction of it. Now we want to divide both sides by 6. That cancels that out. It leaves us with c is less than or equal to. Now, this turns out to be kind of an ugly decimal, but it's about 11.7. And this means that the children must be less than or equal to 11.7. So if we wanted to really answer this question, we would say that the most children that could attend would be 11, because it can't be larger than 11.7. Therefore, 12 children would be too many, but 11 is okay. All right, let me clear out that drawing. Let's move on to problem 2. Now, when you see a negative sign in front of the coefficient with the x, you should immediately be thinking about that rule that we talked about, because we're probably going to end up dividing by a negative number. But let's start our solution. Once again, we are adding something on the side with the x, so let's subtract that. Let's do the opposite. That gives us minus 4x is greater than 26 minus 10 is 16. That's because those two canceled out. Now, as we did with equations, we're going to divide both sides by the same thing, and that's -4. Now, as soon as you divide by a negative number, what I would recommend is immediately coming down here and writing your inequality symbol in the opposite direction. Notice that up here it was greater than, down here it becomes less than. These two cancel out. That leaves us with x here. And 16 divided by -4 is -4. Our answer would be x is less than -4. All right, that wraps up this video. I hope that helps. Now it's time for some practice. Good luck.